चलो वो पोटेंशियल ड्रॉप वाली बात अभी रहने दो, चलो कर देते हैं, ऐसे करते हैं। I will ask you a few simple questions so that you are able to work it out. Actually, in that particular question, there is everything involved. What we do is, we start with two simple questions. Find the potential drop across C2 and the charge on each. Let me ask you one direct one. In which you have to find charge on C1 and C3, potential difference across C1. Three basic questions being given to you, which is going to remind us how to determine the potential difference across various capacitors and the charge on each. Then we will graduate to major problems today. These are basic questions. आंसर आ गया? अगर बेटे दो कैपेसिटर देते हैं फिर दोनों के क्रॉस पोटेंशियल डिफरेंस पूछे होंगे तो देयर इज नो नीड टू फाइंड द चार्ज. We can directly do it. Let's do this the first. V1 कितना? 24 into 4 over 16. कितना आ गया? 6 volt. Very simple. Very simple. We will never forget this. Because for two capacitors, and that is what I am doing in that particular question yesterday. I do not have to calculate the charge to find the potential difference. Whereas, if we have to had the question only been find the potential difference across C2, still I have to find the charge. 12 and 4 is 3. More combination with that. 12 4 is 48. 48 plus 16 is 3. And 3 and 3 is 1. I hope all of you are with me.
Yes,
3 and 3 is 1.5. Jinna charge को 1.5 there. 1.5 into 10. 15 microcoulomb is the charge on the equivalent and also the charge on each. 15 by 4 is the potential difference across. Maybe it's like a song. It goes like a song. समझ आए कि नहीं? दोबारा करते हैं. बहुत important है. The more we do over here, the lesser time we will have in problems on electric current. ठीक है? So FA, this is the equivalent. The equivalent is how much? 1.5 microfarad. This has a potential difference of 10 volt across it. We have to find the charge on it, on this, because 1.5 into 10, which is 15 microcoulomb. This is also Q1, this is also Q2, this is also Q3. Thus the potential drop across this is, 15 by 4 volts. किसके पास था? Good. मैं ऐसे ही कराई जा रहा हूँ. Charge on C1 and C3. ठीक है? Now, had the question only been to find the charge on C3. Okay, C1 and C3. This is 3 and 2, 5 and 1, 6. The situation is C1, okay, C dash, and C5. This is 3, this is 6, and this is 2. And in a सारे ने cross करना 20. If I have to find the charge on C1, I must determine the charge on the equivalent. C कितना आ गया? 1. 3 and 6 is 2, and 2 and 2 is 1 microfarad. I hope things are friendly now. 20 volts. Jazz Mohammed in London. Q, this is 20 microcoulomb, which is equal to Q1, equal to Q dash, equal to Q5. लिख तो लो, whether पूछे या नहीं. It is repetition in our head. Q1 तो हो गया. Now the catch is to find the charge on C3. To find the charge on C3, I must have the capacity C3 and have the potential difference across C3. We know the potential difference across C3 is the same as the potential difference across C2 and C4. But है कितना? Equal to the potential drop across C dash. Good. The potential drop across C dash. I can write this here. The potential difference across C dash is V dash, which is Q dash by C dash. Q dash is 20 to the power minus 6 and C dash is 6. Thus it is 10 by 3 volt is the potential difference across C dash. This is also the potential difference across V2, V3 and V4. Now. It goes like a song really. It's so enjoyable. Q3 is C3 into V3. C3 is 2 into 10 to the power minus 6 and V3 is 10 by 3. Thus we have 20 by 3 microfarad. We can also determine the charge on Q2 and Q4 as required. The catch is that in a parallel combination, if you are asked to find the potential drop across any one, you find the potential drop across the combination. I hope things are okay. चलिए आगे. Okay, I will put forth an NCERT question. Take it. This is 200 picofarad. This is 200 picofarad. This is also 200 picofarad. This is also 200 picofarad, and this is 100 picofarad. And you have a potential difference of 300 volts here, please. And you have to find the equivalent capacity across AB and the charge at H. जी ये भी ओपन है, बैटरी लगी है उसके क्रॉस. How much? Equivalent capacity. No. No? 200 by 3, right out. 200 by 3. Okay, I'll do it. Because there's a small catch here. Please observe, please observe. Chavi. Rub. Rub. Muskan. It will be very clear now. This is the point A. This is C5. Aya nazar? That's it. This is C5. 100 picofarads. This is C1, this is C2, this is 200 all in pico, this is 200, this is 200, this is 200, this is C3, this is C4, C5, C12, C34, C12 is how much? 100. This is also 100. This is also 100. ठीक है? अगर आपने इसको या ढंग से लिखना है, you will have C12 is C1 C2 over C1 plus C2 giving you 100 picofarad. You have C34 to be C3 C4 by C3 plus C4 giving you 100 picofarad. Then you have C dash as C12 and C34 as they are in parallel, giving you 200 picofarads. And now you have C5 and C dash in series. This is 100 picofarads. This is 200 picofarads. This is the point A and this is the point B. And across it you have 300 volts, giving you C to B. 1 by C to be 1 by 100 plus 1 by 200, giving me C to be 200 by 3 picofarads. अंडा दिमाग प्रप कहाँ से बेटे, कहाँ से? जहाँ चार्ज की डिवीजन शुरू हो गई तो वो सीरीज में नहीं होते। यहाँ से चला ना, कुछ यहाँ से चला, कुछ इधर गया, कुछ इधर गया, कुछ इधर गया, जो भी उधर गया वो सेम था, जो भी इधर गया वो सेम था। I've reduced it beautifully. इससे अच्छा नहीं हो सकता। The more you do, the more you learn. Now, we have to find the charge on each. Should we find the charge on the equivalent capacity?
Yes.
Maybe not, because it will give us the charge on C5 only. And as there are two capacitors, we can divide it in inverse ratio and determine the potential drop individually also. Therefore, let me discuss it with you. I basically want to have the potential drop across this, which will give me the charge on this. I also want to have the potential drop across this. Okay? That can also give me the charge on this, but what will I do with it? The thing is that the potential drop across these 2 points is the same as the potential drop across these 2 points. Once I have the potential drop across these 2 points, that is the potential drop across C34 as well as C12. Then I will determine the charge on C34, which will be the same as the charge on C3 and C4. I will determine the charge on C12, which will be the same as the charge on C1 and C2. In this particular question, there is no need to determine the charge on the equivalent capacitor. Had there been 3 capacitors, I would have done it. I can divide it in inverse ratio. Yeah, even if I do it, there is no hassle, because that is another way to find the potential drop across this also. बोलो कैसे करना है?
Inverse capacity point divide हो जाता है, वो equal आ जाता है।
हाँ, वो तो equal आएगा ही आएगा. The thing is over here, this V5, V5 is going to be 300 into 200 by 300, giving me 200 volts. Thus Q5 is how much? Q5 is C5 into V5, which is 200 into 100, which is कितना आ गया? 2 into 4 होना चाहिए। Okay, 4 नहीं पिको कूलम, ठीक है? And इसके क्रॉस कितना आ गया? 100. Therefore V dash is 100. इसको निकालने का एक और तरीका भी है. The equivalent capacity is 200 by 3. the charge of the equivalent capacitor is 200 by 3 into 300. That will be the charge on the equivalent as well as on C5. You can divide it and we're going the other way around. When there are two capacitors, it's very convenient. There's no need to determine the charge on the equivalent capacitor. If you understand this. Okay? V dash is 100. Now, it means V12 is also 100 and V34 is also 100. Okay? Now, Q12 is C12 into V12. C12 कितना? 100 into 10 raised to power minus 12 minus 12 into V12 कितना? 100. कितना आ गया जी? 10 raised to power minus 8. Similarly, Q34. This is what it is saying. This is C34 into V34. This is also. To determine the potential drop across C5, you can opt the other way also. बर्दाश्त कर सकते हैं अभी वाला है
सर पेपर बहुत पसंद है पेपर बहुत पसंद है
ओके बता दो आपने बुक में से किए क्वेश्चंस तो हम तक गया you will have to see the recorded lecture. Okay, I'll give you another one. And equivalent across A and B. One microfarad, please. 1 microfarad. Okay? उल्टा करो 3 3 3 1 1 into 3 3 3 and 2 3 3 3 okay आपको क्या नजर आ रहा है ये बताओ वहम दूर करते हैं what do you feel which one here This is in parallel with what? This two? It cannot be, because this plate is connected here, this is connected here. For capacitors in parallel, two plates should be connected together to one point, and the two other plates should be connected together to the other point, without anything in between. We do not have any of the two capacitors in parallel. And like here, this is connected here, this is connected here. In between there is a capacitor. Okay? So the only thing that we see is that these three are in series. You can imagine one here. Of how much? 1 microfarad. 1 and 2? 3. Now you have a single one of 3 here. 3, 3, 3?
1.
Plus 2?
3.
3, 3, 3?
1.
Okay? Very, very interesting. Let me do with you something more interesting. Let's put a dielectric in the capacitors. Completely filling. Completely filling. Because if it is partly filled, we'll have to do some theory. Okay? When a capacitor is completely filled with when the space between the plates of the capacitor is completely filled with a medium of constant K, the capacity becomes K times. Okay? This is a medium of constant K1 and this is a medium of constant K2. The area of the plates is, actually these plates are like this now. Plates होती हैं, ठीक है? Actually it is like this. Okay? You can draw single line. Now, this separation was D. This is D by 2 and this is also D by 2. You have to find the capacity of the arrangement. Let me guide you. Let me guide you. बहुत सुनना पड़ेगा बेटा. These can be assumed to be two capacitors in series with a zero gap in between them. Half the capacitor had a capacity of epsilon naught A by D by 2. Okay? Half the capacitor had a capacity of epsilon naught A by D by 2. That is multiplied by K1. The other capacitor is epsilon naught A into D by 2 into K2. And these two capacitors are in series with a zero gap in between them. In other words, this can be redrawn as this. This zero gap, the gap approaching zero, and this. ये बन गया. ये सेपरेशन पूरी दी है. ये K1 है and ये K2. C1 कितना होएगा? K1 epsilon naught A by C2 कितना होगा? K2 epsilon naught A by D by 2K1 epsilon naught A by D, 2K2 epsilon naught A by D. 1 by C is 1 by C1 plus 1 by C. 2K1 epsilon naught A by D. क्या कॉमन आया? D by 2 epsilon naught A. अंदर K1 plus K2 by, and the equivalent C becomes K1 K2 by K1 plus K2 into 2 epsilon naught A by, ये बनी कैपेसिटी वैल्यू. Have you realized that the two capacitors are in series? It means we can put a number of mediums in between. We can have a number of mediums in between. Each one will be a separate capacitor. We can also have this of D by 3 and the other of 2D by 3. This means that if a dielectric is filling the place, two different dielectrics are filling the place, then you have, it becomes each separate capacitor. Each one of them is in series because we have an artificial boundary here. We have an artificial boundary here. We can assume two plates at the same potential with zero gap in between them. ठीक है? Absorb करो. Let's do the reverse. What do you think now? Parallel. You know why? See the children. This plate and this plate can be assumed as two separate plates joined here. Here. ठीक है? With zero gap in between them. Here. Here. Okay? I hope you are able to visualize it. I have assumed a zero gap between the plates and the two plates. This plate is joined here. 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 Which makes C1 as K1 epsilon naught. Look at the manner I have written A by 2. I have not written A by 2D. It would appear that D double हो गया. It plates, the area is half. And C2 is K2 epsilon naught A by 2, giving me equivalent capacity as two capacitors in parallel, which is K1 plus K2 epsilon naught A by. आज मैं दोनों छोटी सी असाइनमेंट बना के दूंगा आपको, which I will include the multiple section also and make a small assignment of workable questions. Okay? पहले वैसे ही बना बेटे, पहले वैसे ही बना, ठीक है? और फिर उसको इक्विवेलेंट कर. आपके नोट्स है ना? ओके ओके. SAT paper always on a Saturday?
Yes.
It is.
It is.
Is that why it's called a SAT?
No.
No. Because it is a scholastic aptitude test. According to me, I think they should go off this, the admission to various colleges should be on the basis of such a paper. The level can be different and not really on the basis of your +1 and 2. It's already been checked there. It means we don't even believe our own boards. Huh? It means we don't even believe our own boards. Kamala. That's, we have to conduct a separate entrance exam for it. Because the entrance exam is very dicey. It depends upon a lot of luck. They're gonna. Today I was making a full-length paper for students, and I have discussed so much of kinematics. I want to put so much of it, but I could put only 2 questions. क्या पता क्या? Electrostatics. मत मार दे यार. हैं? 2 ही क्वेश्चन इससे आए ना बेचारे के. पहले सारा प्लान किया मैंने कि भाई every unit, if there are 16 units, 8 plus 8, 9 plus 9, 18, 45 questions. You need 2.5 questions from each. Okay. Entire kinematics, vectors, projectile motion. 2 questions. या वेक्टर के 6 टेस्ट हैं आपके पास. I find it quite ridiculous. IIT पेपर तो मुझे वैसे समझ में नहीं आया कि क्यों डालते हैं ऐसा. When you can score 20% marks and get admission into an engineering college, what are we trying to tell students? The merit should be higher, the paper should be reasonable, so that everybody is able to attempt it. And a student scoring maybe 80 to 90% marks should be getting admission. The merit will remain the same. पर नहीं, दिमाग खराब है. बंद करो यार इसको. Okay. I hope it is clear. I'm going to do a very interesting question with you as you are following things. NCERT question है वो किसी के पास? There is the solved example, which is one of my favorites. Solved example बोल रहे हैं. NCERT लिखा होगा उसमें. सैंपल में होगा या सॉल्व में होगा. ये देखो ये मैंने करवा दिया. And now I'm going to ask you something about them. Now, problem number 7. Make a concept. जोएल पढ़ना बेटे क्वेश्चन का.
An electrical technician requires a capacitance of 2 farads in a circuit across a potential difference of 1 kilovolt.
First, wait. Requirement. क्या है जी?
2 farads.
2 microfarads, which is able to withstand 200.
नहीं, 1 kilovolt.
Which is able to withstand
1 kilovolt.
1000 volts. This means that you have to listen to me very carefully. It's a new thing. There is something called dielectric strength of a material, which is the maximum potential difference that it can withstand. Okay? If I put this capacitive arrangement across 800 volts, okay, it will be charged to its lesser capacity and the energy stored will be lesser. The maximum it can be charged to is 1000 volts, and that is the maximum energy that can be stored in the medium of the capacitor. The moment I put it across a potential difference greater than 1000 volt, it's going to burst. बर्दाश्त नहीं कर सकता. So the maximum it can withstand is, this is the requirement. What does he have?
A large number of 1 microfarad capacitors are available to him.
We have 1 microfarad capacitors which is able to withstand
Potential difference of not more than 400 volts.
अरे वाह, withstand 400 volt. This capacitor we have so many 1 microfarad capacitors, but it can withstand only. You want a capacitance of 2 microfarad. Jay, a simple solution could be, sir, put the 2 in parallel. Putting the 2 in parallel would give me a capacitance of 2 microfarad, which is able to withstand 400 volts only. I want an arrangement. He says, the question is, how many component capacitors should be used and how should we arrange them? लिख लो question, लिख लो पहले. How many component capacitors are required? Let me deal with it as we have less time today. मैं ही करूँगा बेटा. Boys and girls, in such questions, first of all, we must arrange a certain number of capacitors in series without thinking get total capacity कितने. How many capacitors can I arrange in series? Only 2. Why? Because if the capacity is the same, the total potential difference across them will be added up. If I put 3 capacitors, the total would be 1200 volts. But it means I cannot have more than 2 capacitors here. 400 volt across this, 400 volt across this. I cannot add another one in series. समझ आई बात की? So we have to do this. This is 1 microfarad. This is also 1 microfarad, and this can withstand 800 volts. I think we have to put 3 capacitors here. Exactly. उल्टा सोच गए. We have to put 3 capacitors so that it is able to withstand 1000. नहीं. The potential drop I have is 1000 volt. Had I put 1000 volt here, 500 volt would have been across here, 500 volt would have been across here, and it would have got punctured. Do you follow my point? 500 volt here, 500 volt here. It would have got. Why equal? Because capacities are equal. The potential drop will be equally divided. Charge same इस करके है क्योंकि series में. Potential drop same इस करके है क्योंकि capacities भी same है. If capacities are same, then the potential is equally divided. Thus, had I put 2 capacitors only, then 500 here, 500 here. The capacitor can withstand only 400. Thus, I will have to put at least a minimum of 3 capacitors in. सबसे पहले because then each would बेटे अकेले एक क्रॉस कितना होगा 333.3 and it is able to withstand. Okay, बच गया. ठीक है? We have to arrange 3 capacitors in series in one row. We have to arrange 3 capacitors in series in one row. The potential drop across each would be 333 volts. मेरे को 400 वोल्ट चाहिए नहीं है उसके अक्रॉस. वो कहता है इसके अक्रॉस 400 वोल्ट से ज्यादा नहीं होना चाहिए. कम तो हो सकता है, कम तो हो सकता है. If I put another capacitor, that would also give me the arrangement, but I have to find the minimum number of capacitors. How many? Minimum component capacitors. ठीक है? So 3 तो इस तरह लगाने ही पड़ेंगे. This gives me an equivalent of how much? 1/3 microfarads, which is able to withstand 400 volts. I can arrange as many in parallel of this kind. ऐसे मैं लगाऊंगा M. ऐसे. This is consisting of 3 ऐसे. So I will arrange M of this kind, and M capacitors of this kind in parallel will simply add it up, and it should give me 2. M should be 6. 6 into 3, 18. Oh, wonderful. Oh, wonderful. Take it? We can repeat it. Therefore, इतना चलेगा. Total number of capacitors is 6 into 3 equal to 18. This means that the most important thing here is to find the number of capacitors to be arranged in series. I can repeat it for you. He says we require a 2 microfarad capacitive arrangement which should be able to withstand 1000 volts. I have capacitors of 1 microfarad each, which is able to withstand 400 volts. The first thing that comes to mind is put the 2 in parallel, sir. 2 microfarad हो जाएगा. जनाब 2 microfarad across 1000 volts is going to burst. Therefore, we must first of all devise an arrangement of capacitors in series. We must put 3. We must put 3 capacitors in series. 1000 volt when put across 3 capacitors in series, equal capacitors, the potential drop across each would be 333, which is definitely less than 400. If we put 2 capacitors, that would be 500 volt across.
Sir, अगर potential difference को divide करते हैं 1000 और 400, तो 2.5 आ जाएगा.
You cannot have 2.5 capacitors ना.
उससे ज़्यादा 3.
नहीं बेटे फिर एक ज़्यादा 3 हो गया तो फिर okay, ठीक है. 2.5 आता है ना. What he is doing is he is dividing 1000 by 400, giving me 2.5 equal to 3. एक ज़्यादा. But we can visualize it simply because the number is less. We have to put 3 capacitors. If we put 2, अकेले के cross 500 volt होगा. If we put 3, अकेले के cross 333 is okay. We must have 3 capacitors in series. Which the 3 capacitors in series is an equivalent of. I don't have these capacitors. I have this capacitor which is made up of 3 such capacitors. The Pali. This one capacitor of 1/3 microfarad. I can arrange as many as I want. ठीक है? 1/3 microfarad ऐसे मेरे पास M होने चाहिए अगर, which should give me 2. M6. ऐसे 6. This is consisting of 3 ऐसे. 6 3 is 18. 6 3 is 18. Okay? बंद कर दे.